in which we were working, K-mean implementation. So let's just continue with that. Open notebook, upload data, and just let me know. Did you open and did you upload the data? Done uploading.
Yes, ma'am.
So I guess we did encoding as well as a scaling. So once scaling is done, now we have to do the implementation of a K-mean. So already know that K-mean is an unsupervised learning, which doesn't require a label. So even if you look into your data set, there is no label. Only input columns are done. We did some EDA. And now let's try to plot a graph. I mean, try to build a K-mean model. So implementing K-mean model is very simple. So from cluster, import K-means. Just initialize your model K-range and define the number of clusters. So as of now, I'll just define it like 5 clusters. I'll just call my model dot Correct. So basically here, in order to train a model, I'll be using entire data. So did we drop a customer ID column? Okay. Wait a minute. So please drop the customer ID column before you go further. Just drop this and then do the implementation. So it's data.drop, columns equals. Yeah, once you drop the customer ID, just pass your entire data so it will fit it. That's it. That's how you train your K-mean model. Hope it's clear. I want to see like what clusters it has created. So for that, first I'll be creating a copy of my data. So I'll just say data df equals data.copy. And then inside df data frame, df is just your data frame. Okay. Inside that, I'm just creating a new column called as a clusters. So which is equal to call your model.predict. You just need to pass your data. You can see df, you got a new clustered column. And if you want to see the unique values available in a cluster, like how many clusters it has created, so just say dot unique. So, we expected a 5 cluster, so it has given a 5 cluster starting from 0, 1, 2, 3, 4. So this is how K-mean algorithm is implemented. Done.
I'm done, ma'am.
Okay, so 5 clusters are created. We just need to visualize how those clusters are going to look like. So how to plot a graph? So I need to visualize the clusters. Without cluster and with clusters, let's just make use of a scatter plot. So how to visualize the cluster? So I'll be using multiple plots, figure comma, axis equals PLT dot figure, x size equals 5 comma 2. And then I'll be using it will be PLT dot subplot 5 on 1 comma 2. So it's HNS dot scatter plot, data comma, x equals, shall we take? So I'll be taking DF as a reference. So DF in which I want to see the clusters formation between annual income as well as a spending score. You have to take any two variables and you have to visualize. Okay, comma. So it's a first graph. Second graph, SNS dot scatter plot. DF comma, same columns, just introduce hue equals clusters. Comma, hue equals clusters. Don't take data as a reference, take it as a DF because DF has a clusters. So comma, graph number AX equals AX of 1. So what do you think? Have they formed a clearer clusters? Can you see the 5 clusters have been created? Five clusters has been created. So do you feel that there are clearer clusters?
Done, mom.
Done?
Yes, ma'am.
Same way, try to visualize with different variables. You could see kind of overlapping. So this is with respect to annual income and a spending score. Same you can try with age. Still it's overlapping. Let's try with age or annual income. Okay, it's overlapping. Done?
Yes, ma'am.
Yes, ma'am.
Okay. So now we'll try evaluating a model. So how do you evaluate a model? We'll just use from sklearn.metrics. Which not from Salhota score. And what should we pass in order to know like how good is your model? To evaluate a model, like what should we use? Which variable should we pass? You have to pass your data and a labels. Labels in the sense just a clusters. Okay. First create a labels. You know labels in the sense the cluster names, labels equals. So just call model.predict data. Can you see? So we are passing these labels into our Silhouette score just to know how good is your model. I'll be passing my data as well as my labels. Silhouette score is the default. Okay. Well, it's just 0.28. Even we saw when we were visualizing, it was kind of overlapping. When it's overlapping, obviously, the intra-cluster and intra-cluster distances might be wrong. So it may not be satisfying the rule. So obviously the model performance is less. So from this, we can clearly see that clusters are not clearly formed. So now overall by thinking, so what do you think, like, how can we improve the model performance? Like what should be fixed to improve the model performance? What is the hyperparameter in this case? What needs to be adjusted in order to get the proper clusters? So we cannot change data. Data is fixed. We don't have any option of changing our data. What is the hyperparameter in a KV? Hyperparameter is a key. So if you can decide the proper, like how many clusters you need to decide, how many clusters need to be created. So deciding that K value will help in improving the model performance. That's the only way. Okay, so how to do that? How do we select an optimal value for K? How do we select optimal value for a K? Any idea? So for that, we use a concept called as an elbow method. So elbow method basically helps in selecting optimal value for a K. I hope it's done. Is it done till here? Done evaluating? How to select optimal value for K? That's where we use a concept called as elbow method. Elbow method. So what is that elbow method? So when I say elbow, it is a method. Used in K-main to find optimal values for K so that we get clearer cluster. So that we get a clearer cluster. So since the model performance is less, and since we are deciding what should be the K value, you have to use certain approach to decide that K. So randomly, I cannot say like 3, 5, 10, something like that, because So choosing K value matters the most in order to enhance your model performance or maybe to get a clearer cluster. So for that, we use a concept called as an elbow method. So what this elbow method does, how it works. Any idea how it works? So it starts with all the possible values of a K, like starting from 2, 3. A cluster cannot be single, it should be at least 2. So it starts with different K values starting from 2, 3, so on. And then for every K value, it is going to find WCSS. So we'll understand what is WCSS, then it plots a graph, and accordingly, it will try to find what should be the optimal value for a K. So how it works? So basically, it starts with so when I say all possible values of K, it starts like this. Okay, we implement this elbow method for some possible values of K starting from 2, 3, 4, so on. Then for every K value, we need to implement so for every K value, implement K means and find WCSS. You know what is WCSS? So WCSS is basically within cluster sum of squares. So what is within cluster sum of squares? So when I see within cluster sum of square, basically it is a square distance between each observation and a centroid. It's a sum of square distance between observation and a centroid. It's calculated using a formula summation xi minus ci whole square, where xi is observation, ci is centroid. So it is just sum of squared distance between observation and centroid. So this is WCSS. Then what you have to do? So usually this WCSS is calculated for all the k value. So now for every k value, you have to plot the corresponding WCSS. So when you plot a graph, k will be along x-axis, WCSS will be along y-axis, and your graph can be something like this. So wherever you see a break and wherever you see the stability, that point is going to be the optimal value. So we call it like an optimal. So wherein WCSS is like minimum. So this is how we use an elbow method in order to decide the optimal value for a key. Hope it's clear. Clear? Understood? Okay, this is all about an elbow method. So we'll do this implementation to decide a key value. We'll see what is the optimal key value it's going to give us. Okay. So I'll be creating an empty list in order to store WCSS. I'll be using a for loop for x in range of, or you can just take it like a k itself for k in range of 2 to 11. And then you can implement a k-mean model. So model equals k-means. You can define number of clusters equals k. And then model dot fit of your data. And then every time I'll call WCSS and I'm gonna append the values. That is the WCSS in Python is calculated using the formula model.inertia. That's it. Run your model for multiple times, and if you see, you got a WCSS value. So now for this data, try to plot a graph. I'll be using plt.plot. I'll be passing a range of 2 to 11. Along x-axis, y-axis, it's going to be WCSS. And then if you want, you can give a marker. So plt.x label is going to be k. plt.y label is going to be WCSS. If you want to display just a graph, just use plt.shoot. So this is how the graph is going to work. So now you have to decide a k value at the elbow. So where the sudden drop you see. So your optimal k value can be 4. Try implementing your k-mean with cluster 4 and see the model performance. Let me know once you are done till here. Then I'll show visualizing clusters and evaluating.
Done, ma'am.
I'll just create a copy of another data. Df1 equals data.copy. And then I'll be creating the clusters. So before that, I need to train my model with so k equals 4 seems like our most optimal. So I'll try train a model with clusters equals 4. I just created a new copy and I'm just using model.predict of data. So now if you want to see the clusters, .unit. So 4 clusters, 0, 1, 2, 3. Let's just create a labels. Let me just call Silhouette score. And let me pass my data as well as the labels. So it's 0.31. I guess it's improved. Yeah. 0.28 to 0.31. So this is how you choose the optimal value and you try to evaluate your model. Since data set is too less, so we're not expecting, and information is also like very less. So we are not expecting much better results. So since I wanted to show you how it works, so I took a simple data. Okay, but in real world, most of the time you work on supervised and unsupervised, that too regression and a classification compared to your classification. I mean, compared to your clustering, but still it's good to have a knowledge of clustering. If you want, you can visualize and you can see, you can take the same graphs. Instead of 3 graphs, you'll get a 4 graphs now. I mean, instead of 5 clusters, you'll get a 4 clusters. So I'll be using DF1, DF1. Not bad, but still you could see these purple ones are overlapping. These two are overlapping, but these two clusters are like good. So this is how the k-mean algorithm is going to work. That completes your machine learning concepts. Any questions you can ask? Done, clear. You want a break or shall we continue with a new topic, which is artificial neural network? You want a break or should I continue?
It's okay.
I should continue.
Yes, ma'am.
So far, whatever we studied, it's all about machine learning. So I'll be starting with our deep learning. In deep learning, the first concept is ANN. You know what is ANN?
Artificial neural networks.
So ANN, in the sense, it's an artificial neural network. So basically, when this comes under supervised learning, it requires a label data. And also it can be used to solve both regression as well classification. Neural network used for solving regression, we call it like ANN regressor. The one which is used to solve classification is called as ANN classifier. So what is ANN? So important thing related to an ANN. ANN is just a mimic of human brain. Which includes neurons and connected each other. Neural network. So far we have understood our machine learning. So when I say machine learning, it was using all the mathematical equations to learn patterns and also to make up predictions. So when the complexity of a data increases, so obviously the advancement towards the model also increases. That's why people felt like, why can't we mimic something which behaves like a human brain? That's where artificial neural network concept has been evolved. The way we have a nerve systems or a neural system, neural network or a brain system. So we all know that brain is basically composed of different neurons connected with different networks, right? Similar concept is going to happen even in a ANN, wherein the learning is going to happen in a different layers. So it's not just using just a mathematical equations. The process or a learning is happening in a different layers, so that compared to your machine learning model, you can expect a better results. So that's one of the thing. And also, we know that machine learning basically deals with a structured data, that is a data which is available in a table format. What if you want to deal with a data which is images, audio, video, PDF or documents? In that case, we need something advancement we need some advanced model because machine learning alone cannot manage them or they cannot handle it. So we have a concept called as a deep learning. In that, the first one is an artificial neural network, which is just a mimic of human brain. That's going to work like the way human learn things. Same concept is going to work in a ANN. So again, ANN can handle only the structured data. So advancement towards this ANN is we have a CNN, so which is capable of managing our images. So now, so this is related to ANN. So important thing related to ANN is the very first thing that basically comes under ANN is a perceptron. Do you know what is perceptron? What is perceptron? So perceptron in the sense, it's a single neuron in a neural network. Perceptron in the sense, it's a single neuron in a neural network. Let's say, for example, you'll be passing input information like this, and everything will be received by a single neuron, and then it's going to make a prediction. If your neural network as a single neuron, we call such things as a perceptron. So, but not every time your neural network can have a single model. So that's the reason we have artificial neural network, wherein you will have different layers, different neurons connected to each other. So when it comes to an ANN, it's very much important to understand the ANN architecture. So when I say ANN has a three different layers. Any idea what are the three layers available in ANN? So ANN has three layers. One is input layer, and then we have a hidden layer, and then we have output layer. These are the three different layers available in artificial neural network. So now we'll understand what happens in each layer. So what is input layer and what's going to happen inside input layer? So input layer is the first layer in artificial neural network. Which receives input information. So there will be neurons which are responsible for receiving information like this. So we call this layer as an input layer. It's the first layer in a neural network which receives input information from a user. Next layer is a hidden layer. So what happens in hidden layer? So when I say hidden layer, it's a second layer in a neural network. Which can have several layers. Where learning can happen. This is hidden layer wherein actual learning happens here. So it can have several neurons and it can have a different layers as well. So after hidden layer, we have a final layer, which we call it like an output layer. The layer which is responsible for making predictions. We call it like output layer. So this is basically an input layer. This is an hidden layer where learning happens. And this is an output layer where prediction will happen. So all these things will be interconnected. So we call them like a so finally it will be making predictions. So we call this as a neural network. So these are the three different layers available in artificial neural network. The most frequently asked interview question, what are the different layers in artificial neural network? Any questions you can ask? Clear so far?
Yes, ma'am.
Let's understand how ARN works. First up, it's an input layer. Receives information from user. Let's say, for example, you have a data. In our input layer, there will be a neurons which are responsible for receiving the information. Will be sending like this. So then what happens? So we have just input information, right? So basically it receives an input from input layer. That means it is receiving inputs from a user. And then it randomly initializes the weights. In the same input layer, it randomly initializes weights. So now the question is, what are weights? So when I say weights, weights tells us like, how much influence each data point has on output. That's an weight. Next important thing, once randomly initialize the weights, multiply each weight with our input. it will become like this. Okay. What if weight is 0? Since we are initializing weight randomly, what if in case the weight is 0? So the entire x gets vanished, right? So to overcome that, we introduce bias. So to avoid that, a small constant which is a bias. So now our input becomes, how is it looking? How is it looking? Y equals Wx plus B is looking like what? It looks like a straight line, right? So this is what is going to happen in the first layer, which is an input layer. It receives an input, gets multiplied with the weights as a supporting factor, which tells how much influence each observation have it on label. So what if in case randomly initialized weight is 0, that entire input will vanish. So to overcome that, we just add a constant value. So we multiply each input with a weight and we just add the bias. So it is looking like a straight line equation. So this is related to input layer. So now this information has to be passed on to the next layer, which is hidden layer. And you know what happens inside a hidden layer? Is it done clear so far? So when I say hidden layer, I said it receives information from our input layer, and we have already known that inside our hidden layer, actual learning is going to happen. So when I say learning happens, so two things will happen. Summation of all inputs with weights. Second one, we just apply the activation function. So when I say summation of all the inputs, like how your inputs is looking, right? X1, W1 plus B1, something like that. So we need to sum everything now. So your Y is going to be, or you can say Z is going to be it will sum all the information that we are receiving from our input layer. So in general, I can represent this as a summation xi wi plus vi, where I equals 1 to n. This is an equation, you get it with the help of a summation. So once you apply the summation, you have to apply the activation function on it. So it becomes f of z equals activation function will be applied on the summation. An important thing now, what is activation function? This is all about first step, which is summing. So summing all the inputs that we are receiving from our input function. Then applying activation function. So what is activation function? What it does? Yeah, what is activation function? When I say activation function, it's one of the mathematical function which introduces non-linearity into your equation. So activation function is a mathematical function which introduces non-linearity. So why, what is this non-linearity? Why activation function is important? Any idea? So why it's important? Why we use it? If you can look into the way we are receiving an input function, it looks like a linear function. It's a straight line equation. So, but what if your data is non-linear? So when I say non-linear data or when it's related to a classification, So we cannot expect our output to be linear, right? We want it in a different format. We want for classification, we want in either 0 or a 1. So that's the reason to overcome that linearity. So we introduce a non-linearity so that it can also solve problems related to non-linear data or a classification data. Okay, that's a activation function. So we have a different activation functions that we're gonna apply in hidden layer. The most popular one are like ReLU. So we have a tanh, and then you can also use a leaky ReLU. Okay, so this is what is going to happen with the hidden layer. So wherein the actual learning is happening. How it learns? It takes all the information, it will sum, and then on that sum expression, the activation function will be added so that a non-linearity will be introduced just to overcome the linearity. Okay, because everything will look like a linear format. So the most often used activation functions are ReLU, tanh, and a leaky ReLU. So these are the activation functions. Used in hidden layer. So next important one, obviously this information will be passed to the third stage, which we call it like an output layer. When I say output layer, so it receives information from hidden layer and makes predictions. And it's going to make up predictions. So again, this output layer will be using an activation functions because it has to format the output in a way it's expected, right? So if you are expecting your output to be in a linear format, if you're solving a linear regression concept, then it's a linear activation function. If it's a binary classification problem, you can use a sigmoid. If it's a multi-classification, you can just use a softmax. These are the different activation functions used in output layer. Use sigmoid when it's a binary classification. Use softmax when it's a multi-classification. Hope it's clear. This is related to the working procedure of an ENN. Input layer, hidden layer, and output layer. Here so far, understood? So next important thing, what is forward propagation? What is forward propagation? what is forward propagation? So when I say forward propagation, it's a process of sending information from input layer to output layer. Which makes prediction. So we call this process as a forward propagation. So starting from input layer to output layer, the learning is happening, right? Like step by step. It's a forward. We call it like a forward propagation. So you have an input layers, wherein you have a different neurons in our input layer which receives information from user, and then that will be sent to the hidden layer, wherein the two things are going to happen inside those. One is summation, another one is applying activation function. Then that will be passed on to the output layer where the prediction is going to happen. So this is input layer. This is hidden layer. And this is output layer. We call this process as a forward propagation. Think about what is back propagation and just explore. So what is going to happen within a back propagation and also implementation of the CNN, different loss functions, different activation functions, optimizers, all those things we'll discuss in our next class. Any questions? You can ask. Yeah. No questions? Handouts are uploaded. Thank you. Thanks for joining.